Okay, next up is problem number 4, and associated with problem number 4 is number 7. So problem number 4, we have the equation x is greater than or equal to negative 2, which we're going to have to graph. So let's take a look at that one. X is greater than or equal to negative 2. So here we go. And again, I've taken the liberty of graphing these out. So this is x is greater than or equal to negative 2. The next equation is y is less than or equal to 1. So that's here. So y is less than or equal to 1. The next equation is y is greater than or equal to 1/2 x minus 2. So my y-intercept is minus 2, and I go up 1 and over 2. Up 1 and over 2. So this is the equation y is greater than or equal to 0.5 x minus 2, and we have to be above that line there. Right? And then the last equation is y is less than or equal to minus 2x plus 3. So my y-intercept is 3, and I go down 2 and over 1. Down 2 and over 1. So this is the equation y is less than or equal to minus 2x plus 3. Okay, so and we have to be below that line. So I can kind of see my feasible region. I have to be below this line, and then so here we go. So I listed the vertices of my feasible region. It's kind of bounded by these vertices, the navy blue. Okay, so that's my feasible region there. Alright, so now, like before, we have to go ahead and we have to find the vertices. So let me kind of clear this up here, and we have this. And I'll redo this here. And so we need our equations. Clear this up. Let me write this one again, because we're going to need that. So this was the equation y is less than or equal to minus 2x plus 3. Okay, I do have all my equations. So this is y is less than or equal to 1, x is greater than or equal to negative 2. Okay, so here we go. So this vertex here, well, notice here y is equal to 1 and x is equal to negative 2. So there's my system. I have to solve. Y is equal to 1 and x is equal to negative 2. That was easy. And this one here, so notice that's the equation. So I have to solve this equation. X is equal to negative 2, because that's the line. X is equal to negative 2. Again, we don't concern ourselves with the inequality when we're trying to find the intersection. We're looking to see where two things are equal. So we have x is equal to negative 2, and then we have the equation y equals 0.5 x minus 2. Okay, so, well, we just substitute a negative 2 into this x here. So we'll have y equals 0.5 times negative 2 minus 2, so that will give us negative 1 minus 2 gives us negative 3. So I have it. So x was equal to negative 2. Y is equal to negative 3. Alright, so I have that there. Found that vertex. This vertex here, so that's 1, 1. We can verify that. Again, that's two equations. Okay, it's the line y is equal to 1. And then the equation y equals negative 2x plus 3. So again, like before, we said y is equal to y, and we solve. So we have 1 equals negative 2x plus 3. Okay. So y is equal to 1, y is equal to negative 2x plus 3. Set the y's equal to each other. I'll subtract 3, I'll get negative 4 equals negative 2x. Divided by negative 2, I'll get Okay, my bad. Let's see here. So that was actually a mistake here. So I don't know if you caught that, but 1 subtracted from 3 is going to give me -2. I kind of saw that when I looked at the graph and realized that I had to have x is equal to 1. So 1 minus 3 is -2 equals -2x. Divided by -2, so 1 equals x. Okay, so I got 1 is equal to x, and I started with y is equal to 1. So I got the vertex here, 1, 1. Alright? And then the last one here, well, that's the intersection of two lines. So one line is y is equal to -2x plus 3, and the other line is y is equal to 0.5x minus 2. So set the y's equal to each other. So here we go. So minus 2x plus 3 equals 0.5x minus 2. Alright, so I'll add 2 to both sides, and I'll add 2x to both sides, so I'll get 5 equals 2.5x, or 2 equals x. Okay, so x is equal to 2. So I'll substitute. So I'll just take 2 and plug it into that equation there to get y. So y equals -2 times 2 plus 3. So -4 plus 3, -1. So y is equal to -1. So there it is. So y is -1, and x was equal to 2. So I verified all my vertices. Okay. And now we'll just go ahead and maximize the function. But before I do that, let me go ahead and clear off the board. I don't really need all of this anymore now. Oops, let me grab my eraser. Whenever I can get it. Okay, there we go. So I'll clear off the board, and then I will actually maximize the function here. So make this just a little easier. Okay, so everything is clear. Now let me clear off this too. I don't need that. We have our vertices. Alright, so now we have to maximize the function, number 7. So again, we'll make our xy table. X, y, and then we need to maximize p equals 2.4x plus 1.5y. Right, so we got a list of vertices of -2, -3, -2, 1, 1, 1, and then 2, -1. So let's substitute in. So we have 2.4 times -2 plus 1.4y minus 3. And let's see here what we get. So 2.4 times -2 plus 1.5 times -3, that will give me -9.3. So this equals -9.3. The next one, I have 2.4 times -2 plus 1.5 times 1, and that will give me 2.4 times -2 plus 1.5. That will give me -3.3. The next one, we have 2.4 times 1 plus 1.5 times 1. Don't need a calculator for that. That is going to be 3.9. And then the last one, I have 2.4 times 2, which is 4.8, plus 1.5 times -1. So I have 4.8 minus 1.5. And that will give me 3.3. So let's see here. So the largest value I have, well, negative 9, this is going to be right there. Okay, so the maximum function, or the maximum value, is going to occur when x is 1 and y is 1. And we'll get 3.9. Alright? And so again, what did we have to do to solve this problem? Well, we had to do a lot, right? So we had to graph the functions here. We had to find the vertices. Oh, well, before we actually found the vertices, we had to find our feasible region. Then we find the vertices. Then we take those vertices, we plug them into our xy table, and evaluate our objective function, right? So again, we have to do a lot, but that's chapter 3. So I hope this helps.